Hello students, so now we'll start with our next chapter, that is magnetic effect of current. Chapter wise discussion of JEE NEET 2025 January attempt. Let's go for the first question. So first question, he is saying an electron projected perpendicular to a uniform magnetic field B moves in a circle. Okay. If Bose quantization is applicable, then the radius of the electronic orbit in the first excited state is. So either you go by the formula, direct formula is there of the radius, okay, or how we derive that, just the magnetic force, that is Q into V cross B, right? So they are already perpendicular, so that is sin theta is 1. So VB, that I can say, this is equals to mv square by r. From here I can this came QB is equals to mv by r. This is one equation, okay. From here only we calculate the r. R is mv upon qb. This formula we used to remember in the notes, right? Second formula is saying Bose quantization is applicable, right? So we can say mvr is equals to nh upon 2 pi, right? This is also valid. So he said radius, calculation of radius, he told us. So eliminate the velocity. So m into v here, put this value here, put the mv value in this equation. What you got? qbr multiplied by r is there and nh upon 2 pi. Okay. Now he said for the n we can say, he said first excited state. First excited state means n equals to 2, right? N equals to 2 means how much came this? H upon pi, right? From here r get the r square, so that side it will go under root h by pi. Q is what? One electron is there, so E into B. This is what? Pi EB, h upon pi EB. So first option, okay. So your first question answer is first option. Let's go for the next. So next he is saying a proton is moving undeflected in a region of crossed electric and magnetic field at a constant speed of 2 into 10 to the power 5. So basically magnetic field is also there, electric field is also there, but still the proton is moving with a constant velocity, means the electric force and magnetic force are balancing each other. Means I can say QVB is equals to Q into E. This is balanced, right? Okay. And next what he is saying, when the electric field is switched off, so electric field is switched off, the proton moves along a circular orbit of radius 2 cm. The magnitude of electric field is, understand, when you switch off the electric field, only magnetic field is acting, so magnetic field will equated to mv square by r, and this particle will move in a circular orbit, correct? This is what we study. But either I will equate this to this, like this is the value, right? Some value will come that is equated to mv square by r, right? So I can say this equate or this equate, same thing, because these are equal. So I can say Q into E is equals to mv square by r. I know electric field is off, but by magnitude wise they are both equal, right? We have already said that force is equal, that's why only the particle is moving in constant velocity. This is what initially given. So this is also equal. So I can say E that he wants to know, mv square by Q into R. Understood? Put the values. So what he gave here, proton. So proton mass is 1.6 into 10 to the power minus 27 into V square. V I think 2 into 10 to the power 5. 2 into 10 to the power 5 square divided by Q, that is 1.6 into 10 to the power minus 19 into R. R he gave to us 2 centimeter. So you have to put in a SI unit. 2 into 10 to the power minus 2. Okay. This is your electric field. Understood? So x into 10 to the power 4 in something it will come. So you have to get the x. Okay. So calculate. So if you calculate, 1.6 got cancel out and 2 here, 1 2 will be remaining, right? Right? Yes. 2 into, then power you check, minus 27, then here plus 10, then here plus 19. This will come in numerator, plus 19. This will come plus 2. Okay. So I can say 10 plus 19 how much? 29. 29 plus 2, 31. 31, this is 4 only, right? So E will come 2 into 10 to the power 4. So x is 2. So x value is 2. Understood? So x is 2. So second question answer is your 2. Next, third. So he is saying two long parallel, you can see the question. Two long parallel wires X and Y separated by a distance of 6 cm carrying currents of 5 ampere and 4 ampere respectively in opposite direction as shown in the figure. Okay. the magnitude of resultant magnetic field at point P. So here at point P, he is asking the magnetic field. Understand how we will solve. So basically, this wire is this side, right? Okay, so magnetic field is inside the plane at point P, and this is flowing this side. So by this, it will outside, right? So resultant magnetic field we have to calculate. So both will be subtracted. What is the formula? What is the formula? Infinite long wire, right? So magnetic field formula is what? Mu naught I divided by 2 pi r. What is r? Distance from the wire. Okay. So for both of them, if we write down B net, okay. So mu naught is constant and 2 pi is also constant. R and current is changing. So for this wire, I can say 4 ampere and 4 centimeter. Okay. So 4 divided by 4 centimeter. So 4 into 10 is to the power minus 2. Okay. Minus second wire is 5 and this is 10 centimeter. So 5, this is 10 centimeter. 10 into 10 is to the power minus 2. Okay. That's how. Get the B net now. What is that? Mu naught I can say 4 pi into 10 is to the power minus 7 divided by 2 pi, multiply here 4, this is 4 got cancelled out, 100, and this is how much? 100 minus this is 150, right? So this how much came? 2 pi 2 and this is 50, so 100 again, so 10 is to the power minus 5. Okay, so B net came 10 is to the power minus 5, and he is asking value of x. So x is 1, right? So third question answer is 1. Okay, mu naught value also he gave. Next question is a little bit interesting. If you, but we have taught this, right? But if you don't understand, then it will be very little bit of different. Okay, see how. I will tell you, there is a trick in this question. You can solve by the question only. See how. First of all, torsional constant. So we have studied in the moving coil galvanometer also and in the SHM also, right? So by that he is asking the unit in A. So unit, if you, sorry, dimension he is asking, right? So we said torque is equals to C into theta. This C dimension he is asking. Okay. So C, what we will say? Equal, because theta is dimensionless. So it is equated to torque, right? So what we can say? So torque dimension is what? Whatever formula you want to use torque, you can use I alpha. So M L square into alpha. Alpha is alpha, right? So mass length square alpha is what? T minus 2. This is the dimension of C also. ML square T minus 2. Correct. Means A is correct. Fine. A is correct. First, second or fourth option is possible. Okay, fine. Come to B part. Increasing the current sensitivity may not necessarily increase the voltage sensitivity. Okay. Now see. What is current sensitivity? NBA by C. Right? This is current sensitivity. Theta by I. Okay, that's how we calculate. This is current sensitivity. Okay, voltage sensitivity, what you do? Multiply by R. So V, so basically V, right? You want, so multiply by R. In denominator, you divide. So NBA divided by RC. Understood? Okay, so R you multiply, then V into R is what? Sorry, IR is what? V. So that only we want, right? So this is voltage sensitivity, this is current sensitivity. Okay, now see the statement what he is saying. He is saying increasing the current sensitivity may not necessarily increase the voltage sensitivity. Okay. So what you want to do is you want to increase the current sensitivity. Okay. By any fluctuating any value of this 4. Okay. But is it possible that I increase the current sensitivity but voltage sensitivity will not increase? Is it possible or not? Check the variables and then try to do it. Okay. So the answer, the thing is, if you change the number of turns, let's say I make it n times. Okay, double it or triple it. Okay, then what will happen? This will become triple, right? But here what will happen? If the n became n 3 times, then R will also become 3 times. If you increase the number of turns, resistance will also increase, and that factor will get cancel out in the terms of voltage sensitivity, right? So there I can say that current sensitivity will increase, but voltage sensitivity will not increase in that case, right? So he is asking, is it necessarily? Yes, like necessarily increase the voltage sensitivity? Yes, it will not increase. When you will change the number of turns. If you change the magnetic field, then maybe both will be affected, right? But if you change number of turns, then this will increase, but this will not increase. So it is correct. So B option is correct. But if you are not able to see that certain number of turns, we are not able to imagine, right? This I am not able to click it. So read the C statement. Okay, C. If we increase number of turns n, to its double to n, then the voltage sensitivity doubles. Now you have to check. Okay, we read the C. Okay, B part, let's say B part, B statement we left. Okay, and C statement, when you will come, C statement he is saying about this, that if I double the number of turns, will the voltage sensitivity will increase or double? No. Why? Because resistance will be also double. So this factor will get cancelled out. Okay, so this will not change. By this only, the C statement only, I click that. Okay, we can check by the number of turns. Okay, number of turns, if we increase, then this is increasing, but this is not increasing, means B statement is correct. Okay, if you are not able to click the number of turns in the B part, so you can go for the C part first and then come back to B part. Okay, so he is saying that voltage sensitivity will double. No. Okay, because the factor will get cancelled out. D part, he is saying MCG can be converted into an ammeter by introducing a shunt resistance of large value in parallel with galvanometer. No, not the large resistance. We will need a very small resistance so that maximum current can be diverted towards that. Okay, in the previous video we have discussed those things. Okay, that question also came, galvanometer also. Now E part, current sensitivity of MCG depends inversely on number of turns of the coil. You can see by the formula only, it is directly proportional, not inversely. Okay, so I can say this is also, E is also wrong. So A and B are only correct. So fourth option. So fourth answer is fourth. Understood? Next, fifth question. A current of 5 ampere exists in a square loop of side 1 by root 2. Okay, let's assume this 1 by root 2 is A. Okay, let's name this as A. Okay, this is very, very big. What we are saying is this is A. Okay, this is A. The magnitude of, later on I will put the value. And the magnitude of magnetic field at the center of the square loop is, okay, fine, that's all. So what he is saying is, you have a square loop, you have a square loop, and at the center you want the magnetic field. So from this wire, what is the distance? If this the side of the cube is A, so what is the distance? A by 2, right? A by 2. What is the formula of magnetic field? Let's calculate for this particular one wire. Okay. So what is the formula of magnetic field? Mu naught I divided by 4 pi r. That r is distance from the wire, multiply by sine theta 1 plus sine theta 2. Okay. So from here, sine theta 1, sine theta 2, how much? This is 45 only. This is also 45, right? So this is sine 45, sine 45. 1 by root 2 plus 1 by root 2, root 2. Okay. So B will come how much? Mu naught I is given. Okay. Later on we will put the value. Okay. So mu naught I divided by 4 pi, and R is how much? A by 2. A by 2. So this is A and multiply by 2. And sine, this is root 2 will come. Okay. Sine theta 1 plus sine theta 2. Okay. Now what we are saying, that this is B, this will also come, this will also come, this will also come. Let's say if we flow the current like this, right? So all from all it will come. So answer is your 4B. Answer is what? 4B. B net. Understood? So put that value. So mu naught upon 4 pi 10 to the power minus 7. Okay. This factor. Multiply by I. Current is how much? Current is given to you 5 ampere. Okay. 5 ampere current. Multiply by 2 root 2. Divided by, so 1 4 is also remaining, no? 4 divided by A. So A value is how much? 1 by root 2, right? 1 by root 2. So put the value 1 and root 2 will come. So in numerator it will go 2. Root 2 into root 2, 2. Understood? So from here I can say this is 4 4 is 16, 16 into 5, 80. So 8 into 10 to the power minus 6. Okay. 8 into 10 to the power minus 6. So this is P is your 8. Understood? P is what? 8. Next, sixth. So again same wire only is going in the whole chapter, wire. Okay. Long straight wire of a circular cross section with radius A carries a steady current I. The current I is uniformly distributed across this cross section. The plot of magnetic field B with radius R from the center of the wire is given by. Okay. So inside the wire also. So if we keep the wire like this going inside that, okay, this is your wire, okay, in which uniformly current is flowing. Okay. So from first we will calculating inside magnetic field. The formula is in the notes, but see how it is calculated. So if we assume R radius, r radius. Okay, here you want to calculate the magnetic field. So you know the formula, closed integration of B dot dl is equals to mu naught into I inside summation I inside. Okay, this is what the formula is. Okay, so by this formula if you go, so B and dl integration is how much? 2 pi r. 2 pi r is equals to mu naught into, now you will write down the current inside this loop. Okay, this is in 2 pi r, this inside this. Full is what? Let's say capital R radius. Okay, full is capital R radius. Here this is small r. So first you write down the J. Okay, so J, when you will write down, current full is I divided by pi r square multiplied by this area is small pi r square. Right? Understood? That's how you write down the I inside. This is I inside. Okay. B value how much came? So 2 pi r. Here 1 r got cancel out. Okay. 1 pi got cancel out, and you will have mu naught I divided by 2 pi r square into small r. Okay. Understood? This is what we got. B outside you know already. This is inside. B out you know already, mu naught I divided by infinite long wire, right? So 2 pi r, 2 pi small r. Okay. So here inside if we see, so magnetic field is directly proportional to r, right? Okay. So linear relation. Okay. So straight line. B outside is exponential decay, right? What we say, inversely proportional. So first linear increase. Okay. And then after 1 by r relation. Okay. So this will go like this. So fourth option. Understood? Other than that, there is no option matching. Okay. Here you may, if you don't know how to calculate the inside one, then you may be get confused. Otherwise, this is what. Okay. So fourth option is my correct answer. Okay. Again, this question will come on the same. Okay. So we will solve by this formula. You will see one more question is there on this same thing, same formula. See, next question. N equally spaced charges, each of value q, are placed on a circle of radius capital R. The circle rotates about its axis with an angular velocity omega as shown in the figure. The bigger empirical loop B encloses the whole circle, where a smaller empirical loop A encloses a small segment. The difference between the enclosed current IA and IB for the given empirical loop is. Understand? What we are saying is, you consider wire is like this. Okay, in this plane, like this you say. Okay, understood? So I am just denoting 2 points only. This is wire, your wire. This wire is coming outside and then going inside. Understood? Coming out and going inside, and half of the wire is this side. Okay, inside of the plane. Like this, I am denoting just 2 points because this is wire, right? Wire like this. So what he is saying is, A is like this. Total empirical loop A, not B. This is your B. Okay, which is carrying whole wire, right? So charges are flowing like this. Okay, how many charges are there? N into Q. This is the total number of charges. Okay, so these are charges flowing continuously. Okay, so how much is the net current flowing through it? One charge is coming out, one charge is going inside. So net current is 0. Total net current is, one is positive, one is negative, right? So total current is 0. So I B will be 0 directly. Okay, now come to A. He is saying A is like this here only. This is A loop. Okay, so for A, IA, when I will write down total number of charges that is flowing divided by total time taken in that flowing the charge. So I can say N into Q charges will flow. Okay, in how much time? One circle it completed, right? What is that? Time period, right? Time period is what? 2 pi by omega. 2 pi by omega. That's it. Okay. N number of charges flown in particular time. Charge flown per unit time. That is only the current, right? So this is only we got. How much this is? NQB omega divided by 2 pi. And then subtract 0 this is. So NQ omega by 2 pi. NQ omega by 2 pi. NQ omega by 2 pi. So fourth option. Okay. So seventh answer is your fourth option. Understood? Now let's go. Eighth question. Eighth question you have statements. Okay. An electron in a certain region of uniform magnetic field is moving with a constant velocity in a straight line path. Okay, magnetic field is there, but still he is moving with a constant velocity in straight line. Is it possible? Let's check. So we say that force formula is what? Q into V cross B, right? Okay. When this cross product is 0, then your force is 0, right? So when cross product can be 0? When the sine theta is what? 0. So sine theta is 0 when? Either 0, theta is 0 or 180, right? So either both are moving in the same direction or just opposite. Your particle is moving opposite to the magnetic field. Then it will not experience any force. So he can move in a straight line. Okay, that time. So I can say, now reason you read. The magnetic field in that region is along the direction of velocity of an electron. Yes. Okay, then only your cross product will be 0, and then you can say that okay, force is 0, so you can move in a straight line path. Okay, so reason is also correct, this statement is also correct, so both is possible. So we can say third option. Understood by this simple formula, this formula. Okay, next, ninth is saying a tightly wound long solenoid carries a current of 1.5 ampere. An electron is executing uniform circular motion inside the solenoid with a time period of 75 nanoseconds. The number of turns per meter in the solenoid is okay. See, first of all, magnetic field in solenoid is what? Mu naught Ni. Okay, this N he is asking. Okay, so he is saying time period is given. Okay, time period is what? 2 pi by omega. Okay, and what is omega? Omega is what? QB by M. QB by M, so M will come in numerator. How this formula came? Simple, the same thing. MV square by R is equals to Q into VB. Okay, from here one V got cancelled out. Okay, and then this V you put R omega. R omega divided by R is equals to QB. So from here omega is equals to R got cancelled out, QB by M. Understood? That's how I put value. Time period came. Okay, B value you put here. What you got? Time period is equals to 2 pi M divided by Q. B value is mu naught Ni. Okay, and he is asking take the N this side, time period this side. Okay, so do that. So this is I into T, and this is here N. Okay, so this value, N value you have to calculate. So if you put the value, what you will say? 2 pi into M. What he is saying? Tightly wound solenoid is carrying 1.5. Okay, 9 into 10 to the power minus 30. Okay, 9 into 10 to the power minus 31 divided by charge. Charge he gave or not? Charge 1.6. Okay, electron only. 1.6 into 10 to the power minus 19. 1.6 into 10 to the power minus 19 into mu naught. So mu naught is what? 4 pi into 10 to the power minus 7 into current is given 1.5. 1.5 into time is given 75 nanoseconds. So nanosecond means 10 to the power minus 9. Understood? This value is your N. Okay. From here, looking very complex, but if you solve, okay, if you solve, you will get N is equals to 250. Very easy. 250 number of turns per unit length will come, or your answer. Understood? Small n is that only, number of turns per unit length. Okay. So this is your answer. How much? 250 your answer will come. Okay. You can check, you can verify the calculation, you will get your answer. Okay. Next, 10th question. This question I would say, once you read it, okay, if the people who will understand that thing, you have to leave this question in initial stage. First you leave this question, do other questions, complete your paper, then come back and then do this question. Why? This question is lengthy. Okay, this will take time. So if this is also giving 4 marks, other question is also giving me 4 marks. So why would I invest so much time on this initially? Okay, by the same question will come, easy question, I will do it very fast and I will score marks, right? This question is lengthy, so initially left it and later on we will do it. Okay, if we have the time. Now see how we will do it. Why it is lengthy? If you want to understand, see here, what he is saying is, if you read the question, consider a long thin conducting wire carrying a uniform current I, a particle moving capital M charge Q released at a distance a from the wire, the speed V naught along the direction of the current in the wire. The particle gets attracted to the wire due to the magnetic force. The particle turns around when it is at a distance x from the wire. The value of x is, okay. He is saying you have a wire current carrying I, okay. At a distance a, you left a particle with this direction, same as the current direction v naught. Okay. Now magnetic field is inside the plane, so v cross b, this side force will attract. Okay. This particle will come close also. This side it will go like this. The particle will go like this. Okay. And it will turn back with a velocity v naught only. Okay. Now what is happening is magnetic force is acting, but the magnetic force is variable. That you understand. Why? Because magnetic force is variable. Why? Because the magnetic field, as you are coming close, magnetic field is changing. Okay. So magnetic force is also variable. Okay. So there are integration is there. Okay. That will take the time. This is not a circle. If magnetic field is constant, then it will be a semicircle will come, and then you can solve directly by answer. Okay. By the formula. But this is not the way it is answered. Okay. That's what the thing is. Okay. Now see how we will solve this. First of all, how I wrote v naught here only. Okay, and I will say when he will be exactly velocity will be horizontal somewhere here v naught. Okay, that will be also v naught. Why? Because the force will be perpendicular to the v naught, right? Then we will write down magnetic field q into v cross b. Okay, so this force this will be perpendicular to the velocity and magnetic field both. Okay, that's why I am saying v naught will not change. Net velocity will be that only. Okay. Now see how we will solve. First of all, let's mention the variables. Some of the that we will say. This is, he said already, this is a where he left. Okay, and this we will mention as x1. Okay, and here this point we will mention as x. Okay, that he wants us. Okay, understood? Now see, let's assume a general point. Okay, so general point, if we say, so it will have a vy component of velocity, okay, which is continuously decreasing. Okay, and there will be a component this side. What is that? I will say vx. Okay, let's mention it vx. Okay, this is general point. Between this point and this point, let's mention this as a, this is b, this is c. Okay, so first of all, I will solve from a to b. How much is the x1? Okay, that I will solve when the velocity became horizontal. Okay, so this is vx, general point. So let's assume a general distance r is there. Okay, from this point. Okay, now let's solve. Now how we will solve first? Okay, first of all, let's get the magnetic field at general point. This, what is the magnetic field for us? Okay, so I can say infinite long wire, so directly mu naught I divided by 2 pi r and minus k cap. Understand how minus k cap? Current is flowing this side, so minus k cap inside the plane. Okay, then you write down velocity vector. Okay, so I know this is the velocity. Okay, why I am solving from here to here? Because here the velocities will change. Here what will be there? Here velocity will be like this. Downside will be your vy, and this side, which side? Vx. This side here vx. Okay, that's why I am not solving here. I am solving from a to b only. First of all, okay, that's why, because velocities will change. So I want to write down in a vector form to get my correct force. Okay, so that's why I am not solving this. I am solving a to b. A to b. Okay, that's it. Velocity vector, if I write down, vy is positive, vx is negative. Okay, so I can say minus vx I cap, okay, and plus vy j cap. Understood? Got it? Now let's write down the force. Why I am writing this? Force I will write down. I will get the acceleration. Acceleration I will solve, and I will get the distance. Okay, acceleration and distance relation I have, because b will come, cross product r will come. Okay, so acceleration and r relation, distance is relation I have. From there I will integrate and I will get my x1. Okay, see how. Just have some patience. Okay, so q into v cross b, I can see v cross b. Understood? Do the cross product. So v cross b, first of all, take all constant outside. For time being q, because I am doing just cross product only. So q v naught I u naught, and here what is remaining? 2 pi r. R is also for time being just a cross product only, right? So r I can take outside. Cross product, if you do minus minus plus, and I cross k, right? I cross k, if you go, what will be there? Minus j. What will be there? Minus j. So minus vx j cap, right? Minus vx j cap. And then after you see j, this is minus, one minus is there, and then j cross k. So j cross k is what? I. Okay, So this will be minus I, minus Vy I cap. That's what your velocity, the force is. Okay, minus Vx j cap and minus Vy I cap. Understood? Okay, that should only come, right? Because this is the direction of velocity. So my force direction will be this way. So Vx is also negative, the Fx is also negative, Fy is also negative. Both component will be negative only. So I don't have to bother about. My answer is correct. I'm just verifying. Small verification. Okay, understood na? Velocity vector is this direction. Force vector is this direction. So one component this, one component this side. Okay, so both are correct. This is my force vector. Now see, I want to solve in x direction. Everything is in x direction. So I will get the x component. Only x component of the force only I will use. So I will say m into ax, acceleration. Okay, what is the x component of acceleration here? This force. What is this? This minus Vy and this component. So I will write down minus q mu naught I divided by 2 pi r Vy. Understood? This is my acceleration component. Okay, with the sign I will write down because velocity is also there, right? Okay. If you don't write with the sign, answer will not come. You will feel that answer will come wrong. That's what later on you will observe. Because this is the acceleration you are writing. So rate of change is there, so you have to write down with the sign. Now see. Next what we are saying is, basically this is r, okay? R is what? Distance only, right? Okay. And this is what? Second derivative. Okay. So that's it. So what you will write down now, r is there, right? Generally what we say, if you remember from the kinematics, if we have acceleration in terms of x, then what we use? Do we use the formula dv by dt? No, we use v dv by dx, and then some dx, x variable is there, right? X is there, okay, in this equation. So we take dx that side and integrate both sides, right? That's what we do. Same thing here also. Here x, instead of x there is r, okay, right? So I will write down that formula. For acceleration, what you will write down? Vx dvx divided by dr. Understood? Instead of dx there is a dr. This is ax, so vx dvx, okay, is equals to minus q mu naught I divided by 2 pi r into Vy. Okay. Now as Vx is changing, Vy is also changing. So Vy is a variable. Take the Vy this side. Okay. What you will have? You will have minus V took this side or no? M is there, M you take that side. Okay. Send the M that side. So if we send the M that side, multiply by M. Okay. Now you have Vx dvx divided by Vy is equals to minus q mu naught I and then dr by r is there, okay, and this side 2 pi m is, right? 2 pi m is there, okay. Now see, now the thing is Vy is also changing with the Vx, right? So what is the relation between Vy and Vx? I can say this is the relation, na? We can say that Vy and Vx resultant velocity will be V0 only. So I can say Vx square plus Vy square is equals to V0 square, always valid, right? Understood? So by this formula, if I apply here, what we say, Vx dvx divided by under root of V0 square minus Vx square. Now everything came in x only. This is constant, V0 is constant, right? So everything came in Vx. Okay, this side minus q mu naught I 2 pi m, this is constant, integration dr by r. Here also integration. Now what is the limit? See the limits. R is changing from where to where? R is changing from a to x1. So lower limit is a and upper limit is x1. Okay. Vx is changing from where to where? So initial Vx, if you see, initial what is the velocity in x? 0. Final velocity V0. Okay. Understood? So here 0, this is V0. Understood? Got it? Now see. This integration, when you will solve, so by substitution we can solve. I hope if you give JEE Main, you know how to integrate, right? Mathematics. This is very easy if you have studied the integration, right? See how? You will use the substitution. V0 square minus Vx square is equals to some z square, let's assume. Okay. So if you do that, differentiate this, what you got? Minus 2vx dvx is equals to 2z dz. Okay, from here I can say vx dvx is equals to minus z dz. Okay, this is your substitution. Understood? Let's substitute and then get the answer also. So limits also will change. So limits 0, vx is 0, so z is v0. Okay, and then when v0 vx is v0, then the z is 0, so this is 0. Now put the limit, so this is minus z dz, so minus z dz divided by, here it will come z. Okay, so this became minus dz only, minus dz. Okay, is equals to, here integration if you do, so 1 minus is here, put that minus also, so minus q mu naught I divided by 2 pi m, this is ln r dr by r, ln r in value you put ln of x1 by a, correct? Okay, these are the values. Now see how we will just integrate it. So minus z, minus will come, minus will become plus, so v0 will come here this side, and this side you have minus q mu naught I divided by 2 pi m ln of x1 by a. Understood? Okay, then after get the x1, we want the x1, so x1 value what you will put, so a will be multiplied, then e raised to power minus, you will have 2 pi m v0 upon q mu naught I. This will be the value of x1, but this is not the final answer. We have to get the x, right? We have to get the x here. Understood? So we have integrated from a to b. Now see how to integrate from b to c. Okay, same kind of integration, little bit of change. What will be the change? Velocity will change here. Okay, so what are the changes in velocity? What we can say, this is vx this side and this side vy. Okay, so here vy direction change, so minus will come here, so force also, the k cross j, the minus here it will come plus, that's it. So that only we have to see how to write down. So see here, first of all b will be how much? Mu naught I upon 2 pi r into minus k cap. This will be your magnetic field for a general point. This is also r only, general point you take r only. Okay, here also this is r. Okay, not a problem. Okay, then you will write down the velocity. So velocity I can say that your vx is in I cap only, minus I cap, right? Vx is in minus I cap and vy also minus I cap, minus j cap. So minus vy j cap. Understood? This is okay. Now when I will write down the force when I will write down, what is the constant? Q into v cross b, cross product. So I will apply the cross product, q into, so this constant outside, mu naught I divided by 2 pi r, and then you will do cross product. Okay, so cross product same thing, just one sign will change. So minus vx j cap plus vy I cap, minus vx j cap plus vy I cap. This will come. Okay, you can solve. This will come the cross product. Just one negative sign is here. Okay, this is your force. Still, I want to solve in x only, right? So I will take the x. So what is my x direction? M into ax is equals to, but I have this constant, so q mu naught I divided by 2 pi r into vy. Okay, same integration. A, what you will put the value of a? Now I can replace here only, right? I hope you understand. So m value I take m that side. Okay, and this side ax, what you can write down? Vx dvx divided by r. Okay, take the r that side, dr, sorry. Okay, acceleration is what? V dv by dx. Right, this formula you know from the kinematics. So from here dr, take dr that side, vy this side. What you will have? You will have vx dvx divided by vy is equals to q mu naught I divided by 2 pi m into dr by r. Okay, integration. Okay, here vx and vy value, what we can put? Vy is what? Same thing, v naught square minus vx square. Okay, understood? in x limit is what? See the x limits. Okay, x limits if I see, so x is changing, sorry, Vx is changing from where to where? Vx is initially V0 and finally 0. So initial V0, final 0. Initial V0, final 0. And R is changing from where to where? R is initial x1, final x. Initial x1, final x. This is my, what we say, R value changing, right? Correct? See now. So from here again substitution is what? V0 square minus Vx square is equals to Z square. So we can say minus 2 Vx dVx is equals to 2Z dZ, and my Vx. So from here I can say this came minus Z dZ. Okay, minus Z dZ. So Z will be in denominator, so minus dZ is your integration. So see, V0 to limits also will change, na? So Z dZ, the negative sign is there, is equals to, here this side, what is the integration? Q mu naught I, limits I will put, just hold on, 2 pi m, here ln x by x1. Okay, here when you will put the limit, what will the limit? So when Vx is 0, what is the value of Z? 0. And when the Z cancel out, no, divided by Z is also there. So this will get dz only. So minus dz. Minus dz. Okay. And here when you will put upper limit. So upper limit when you will go to 0, you put V0. Okay. So V0. So what we got integration, after integration, what you will get? Minus V0. So minus V0 is equals to this thing. Okay. Q mu naught I 2 pi m ln of x by x1. Okay. That's all. So get the value of x. So if I write down x will come x1 into e raised to power minus, slide down little bit down, it's equals to x1 into e raised to power minus q mu naught I divided by 2 pi m. Sorry, q mu naught I, hold on. See here, this will go in numerator, na? This will go in numerator. So 2 pi m into V0. 2 pi m into V0 divided by, denominator will come, this will go in denominator. So q mu naught I. Q mu naught I. This will be your answer. But x1, he is not asking the answer in terms of x1. x1 you assume, na? So put the value of x1. What was the x1? x1 we have calculated this. Okay, same value, but a was there. Okay, that's it. So here I didn't wrote correct, mu naught I. Okay, so here just a is there. Put the value of x1. So x1 value will put a into e raised to power. So when we write down that x raised to power a into x raised to power b, how you write down? X raised to power a plus b, right? That's what here happening. E raised to power there from x1 will come and e raised to power already there, right? So that will get added. This will become 4 pi m V0 divided by q mu naught I. This will be your final answer. So in the power you have 4 pi. Okay. 4 pi m q naught. So first option. Okay. Now you can see how much time it took for the proper integration and solving. So that's how you solve, and your answer is 10th option answer is first option. Okay. Now see next question. I hope you understand. Just see now how I will click in the exam that I have to leave this question. See here, that I told already, but still I will tell you here. As you are going close, okay, your magnetic field is changing. Understand this point. Magnetic field is changing, so magnetic force will change. Force is variable, so integration is there. Okay, that's why this question is lengthy. Okay, now see next question. So next question is saying again infinite wire only, like one side infinite. See this question, exact question is in the notes, exactly same. An infinite wire has a circular band of radius a and carrying current I, as shown in the figure. The magnitude of magnetic field at the origin O is, okay. So if you see, there are two wires. One wire is infinite, one side infinite, okay, and another wire I can say from here, this side infinite, okay, and this is a half of the circle means 3 pi by 2. Okay, so just apply. All the magnetic field will be in the same direction, this also and this also, right? So both will be get added first of all, and from this wire, understand, first of all, this wire is there, right? The upper wire, this will get 0. Why? Because O is on the line only, so R became 0, so no magnetic field, so that magnetic field is 0. Okay, by this wire, what will the magnetic field? See, so by wire, one wire is 0. Okay, so another wire, what is that? Mu naught I upon 4 pi R. What is our distance from the wire? A, right? So A, 4 pi A sin theta 1 plus sin theta 2, right? 1 theta is 90 and 1 theta is 0. Okay, so 1 theta is 90, so 1 will come, multiply by 1. Okay, B of that circular arc, okay, this will come how much? We know mu naught I upon 4 pi A, radius is A, right? So 4 pi A multiply by the theta. Theta is what? 3 pi by 2. That's it. How much is the theta? 3 pi by 2. 3 pi by 2 only, right? From here, 3 pi by 2. Complete. Okay. Third, fourth, 3/4 of the circle. So 3 pi by 2. So this is just add both of them. Okay. What you got? Mu naught I upon 4 pi A common, and then you have 3 pi by 2 plus 1. Okay. So 3 pi by 2 plus 1, 4 pi, fourth option. Okay. So 11th answer is your fourth option. Okay. That's it. This is all. 12th question. The 12th question, again the C. This question I was talking about. That this question is same as to which question we have solved. This one. Okay. This magnetic field we solved. Okay. Inside and outside magnetic field we solved. Na? Same question is here. He's talking about the same magnetic field. Again at a distance of, like, when the maximum magnetic field, where is the maximum magnetic field? This point at the A, right? And then after he is asking where are the magnetic field, half of that. Okay, tell me this point and this point, where it is half. Okay, so that you have to answer. See now how we will answer. So by the formula if we go, okay, formula, there only I will solve. Here is that. Okay, B inside and B outside. Okay, so B max, if you write down B max, okay, let me change the pen, keep it this one. B max if you write down, so that is at A. Okay, so put the value of A. Okay, so what we got? Mu naught I upon 2 pi A. Okay, now he is saying what is the value of B. Okay, so inside, for the inside one, if we solve inside one, there will be one point inside and one point by outside. Okay, by the graph you can see. So he is saying, so mu naught I upon 2 pi A square into R. Okay, this R value you have to answer. Should be half of the B max. Okay, B max is how much? Mu naught I upon 2 pi A. Get the value of A from here. So if you solve, what you got? There is this 2 pi cancel out. Okay, and then this one A got cancel out, mu naught I cancel out. Okay, R is equals to A by 2. R is equals to A by 2. So one point is R equals to A by 2. Okay, next. So then he is saying for the outside point, if you solve outside point, we will say that mu naught I upon 2 pi R is equals to half of the maximum magnetic field, mu naught I upon 2 pi A. That's what. So what is the value of R? So if you see here, 2 pi got cancelled out, R is equals to 2A. R is equals to 2A. So one point is A by 2 and another point is 2A. So A by 2 and 2A. So third option. Okay. How we solve? This way. See. He is asking what are the points where the magnetic field is half of the maximum magnetic field. So maximum magnetic field, half of the maximum magnetic field here and here. Okay. That you have to answer. Understood? Got it? That's what he's asking. You can read the question. Okay. Same question. So everywhere wire. Okay. So next 13. Magnetic field inside a 200 turn solenoid of radius 10 cm is 2.9 into 10 to the power minus 4. If the solenoid carries a current of 0.29, okay, then the length of the solenoid is, okay. First of all, magnetic field formula. This also we have wrote. Magnetic field formula is what? Mu naught Ni. Okay. B is equals to N is what? Number of turns per unit length into I. Okay. B, so length he is asking. So length is mu naught Ni divided by B. So put the value 4 pi into 10 to the power minus 7. Number of turns 200 into current 0.29 or something, right? 0.29 divided by B value is given 2.9 into 10 to the power minus 4. 2.9 into 10 to the power minus 4. If you solve from here, okay, this is in meter, right? Okay, he is asking pi centimeter, means pi factor. He is saying that don't solve the pi, keep it outside and answer me in the centimeter. Centimeter, if you answer, this is 10 to the power 2 will also come, okay, and you have to take the pi outside. So if we remove the pi, pi you remove, because in pi centimeter only is asking. This is what he is asking, okay. So pi you can remove. So 4 will come, okay. That's what he is want us to solve. So if you cut this is 10, okay. Now solve 4 to the 8, okay. 8 into 10 to the power minus 7 is here, and then plus 2 is there, then plus 2 is there, and this is minus 3, plus 3 will come, okay. 3, 4, the 3 plus 4, 7, 7, 7, 0. This will come 8 only, okay. So 8 pi centimeter is your answer, okay. So 8 is your factor that he is asked, okay. Understood? Question number 13 answer is your 8, okay. I hope this is clear. This is what is about this chapter. Thank you.